All right, everyone, so you should only be watching this video after you have completed the Unit 1A study guide. So this study guide will be in Canvas. After you have completed it once, make sure you write down or check which answers you missed or which questions you missed. Then in this video, if you missed a lot of questions, like if you got a 50% or less, watch this whole video because you're missing kind of a lot. If you got a 50% or better, or higher than a 50%, you could just skip around in this video and look for the sections in the video where I talk about questions you missed. For example, if you only missed, like let's say question number 2, you can skip ahead in this video to where I talk about question 2, and that's all. So for some of you this will be kind of quick, some of you this might take a little extra time. It just kind of depends how you did. So we'll go ahead and get started. Number 1, it tells us that triangle T1 and T2 are congruent. So these are the same triangle. And it asks what single transformation could be used to turn T1, and you can't really see it, but there is T1, and this one is T2. So what happened to T1 to turn it into T2? So let's see, it's clearly not a dilation, so we know it's not going to be D. Reflection, well, if it was a reflection, it would just be right above itself or right next to itself, but it's not. So it's not any type of reflection. It's a rotation. If I were to take this and turn it, or even just turn my head or turn the camera, you can see that the triangle would end up, backwards. You can see that the triangles will swap places, just like that. So this one, number 1, it is a rotation. For number 2, this one, it shows us this parallelogram, PQRS, on the coordinate plane. She's going to translate the parallelogram 2 units down and 2 units left to form a new shape. So if it's 2 down and 2 left, okay, it's just a translation, and it asks us to make a statement regarding this new shape. So option A, it says that the new shape will have an area 4 times the area of the original, and that's not true. This one says it'll be 2 times the area, and that's not true. C says half the size of the area, and that's not true. The answer is that the area will be equal for both of them. Just because a translation happened does not mean the area changed. The only type of transformation that would change the area of the shape would be a dilation, because otherwise a translation, reflection, and rotation, they maintain the shape and size of the original, but maybe not the same position. For number 3, it says that Mr. Pruitt draws 2 figures, F and F prime, for his students. Figure F is transformed, is transformed to F prime. The 2 figures are not congruent, so that's very important. The fact that they are not congruent kind of narrows it down. He asks his students to write transformations that could map them. And if you remember our notes from yesterday, there is only one that will result in a similar but not congruent shape, and that is a dilation. So, who responded correctly? That'd be Jalen. Jalen's the only one who got it right. A reflection will not change the shape. So a reflection, the shape will be congruent. Same with rotation, same with translation. For number 4, a polygon is rotated 180 degrees, then reflected about the x-axis. What could be said about the resulting image? So there was a rotation, and then a reflection. So option A, it says the image is both similar and congruent to the original. And this one is what we want, similar and congruent. Remember the definition of similar. It has the same angles, it has the same side, it has the same shape, but it might be a different size. Might be. If it is the same size, it is still similar and also congruent. Congruent just means it is identical, which is what these 2 shapes would be. Rotation and reflection are both similar and congruent. For number 5, quadrilateral MNPQ is reflected about the x-axis, then translated 2 units down to form a new quadrilateral. Which statement is correct regarding the original quadrilateral and its image? So option A, it says that the quadrilateral has half the area. No, because again, reflection, translation, so that shouldn't have changed. 2 times larger? Nope. The 2 quadrilaterals are the same size but different shapes? No. A reflection and translation means they are still the same shape and the same size. So the answer would be D for number 5. For number 6, this line segment is shown and it has a length of 10 units. So we know this line is 10 units long. It then says he translates this line segment 3 units up to form a new segment. So 3 units up, my new shape would be just like that. Now it asks, what is the length of this new line segment? You don't have to actually try to count. Okay? If you are spending time counting on this one, you're doing something wrong. It's a translation. Did the length change? No. Translation does not change the size of an image. So the answer is it's still 10. All right? Be careful with that. Make sure you're not counting. For number 7, it shows this triangle on the coordinate grid, and it asks us to dilate it with a scale factor of 1/2. So right away, we know if we are multiplying this shape and cutting it in half more or less, it's not going to be A, and it's not going to be D. The problem is that both B and C are the correct size, but the coordinates are a little different. So we have to see what would be the correct coordinates. So I'm just going to move the camera closer, and then we'll talk about one of the coordinates. So I'm going to focus on G right here. So G has a set of coordinates. It looks like it is 2 over and 2 up. So that'd be, -2 and +2. So if I used a scale factor of 1/2, which is to say I multiplied that by 1/2, I should get, so half of -2 would be -1, half of +2 would be +1. This should be my new coordinate, -1, +1. And if I take a look at both B and C, we're focusing on G. So G should be at -1, +1. So -1, +1, -1, +1. Yep, so the answer should have been C, but it almost looks like B would have been correct at first. Because you would think to yourself, just at a glance, you could think to yourself, oh, it looks like the original is farther up in the corner, so I guess it must be B. Make sure you're, use that little knowledge about the size of the dilation to rule out 2 answers, but when you have 2 shapes that are a dilation, don't always assume that they're going to end up right where they started, because they could shift out that way, but they could also just as easily shift inward. So watch out for that. For number 8, I don't know why number 10 did that, but all right, whatever. But number 8, it asks us which of these diagrams is a reflection, and that's going to be A. A is going to be a reflection. B and D are both translations, and C, that would be a rotation. For number 9, it tells us a point undergoes a 90-degree clockwise rotation and then is reflected, and it asks for the coordinate. So this is where I'm going to pause and tell you, you should have some graph paper handy. So the coordinates are -3, +5, so I'm just going to go ahead and draw a quick little graph. Let's see, -3, +5, so 1, 2, 3, 1, 2, 3, 4, 5, right here. there's my original. All right, so I've got my original, and then they say there is a 90-degree clockwise rotation. So 90-degree clockwise, so my point should be going over there. So I'm going to turn my paper. Okay, so it looks like the new point is going to be at +5, +3. So 5, 3 after the rotation. Let me go ahead and write that. So 5, 3. Okay, so that's just the rotation. Now I have to do something else. It says we are then reflected about the x-axis. Okay, so x-axis right here. So now I'm going to reflect it. So 1, 2, 3, 1, 2, 3. Right there. That would be my answer, which is at +5, -3. That'd be my answer. So let me make sure that's one of the answer choices. Yep, +5, -3 right here. There will be some questions like this where it will ask you to do a rotation or reflection or dilation or something else, and you might not have graph paper with you. You need to have graph paper with you. Don't be trying to do a quiz like this that is almost entirely graphing based without graph paper. That's just foolish. There's the rest of number 10. So number 10, looks like part of it is way off over there, but this one, it gives you a rectangle and it tells you that there is a 90-degree clockwise rotation. And it asks, what transformation did she perform? So we are going to, let's see, the rotated rectangle shown. Let's see, oh, she rotated. I thought it was saying this is the rotated shape. Okay, so here is the shape, but we are going to rotate it 90 degrees clockwise. So obviously, if you're on your Chromebook, you would have to turn your Chromebook for this one, but 90 degrees clockwise. So I'm going to turn 90 degrees. So now I see my shape should look like this. It should be right from the middle, 2 over, and then I believe 4 down, and that will form my rectangle. And if I look at my answer choices, it looks like it's going to match A. A is the one that starts in the middle and goes 2 over and then 4 down. Just like this shape would be if I turned it 90 degrees. All right, moving on to number 11. This one is asking, what transformation did Tori perform for this one? So went from figure 1 to figure 2. So this is the original, and this one is new. Okay, so old, new. So option A, she translated each vertex 7 units to the right. Well, that doesn't sound bad. Let me just double check that it is 7. 1, 2, 3, 4, 5, 6. Yep. So, I mean, that works. I'm not going to do that for every single point. I'm just going to assume that each one is right. And let's see, for B, she translated each one 7 units left. Definitely no. This is what you might have picked if you didn't realize that this one was the original. C, she rotated. No, if it was rotated 90 degrees, it'd be facing a different direction. And rotated 180 degrees. No, if it was 180, the shape would have wound up down here. So it is A. For number 12, number 12 has a bunch of different options and not all of them are wrong. In fact, only one of them was wrong. This one, it shows 2 shapes. We have an original over here, and we have the new shape over here. And 4 different students said 4 different things, but oddly enough, only one of them is wrong. So A, Roland, he says that it is reflected about the y-axis. Well, if this is my mirror, I can count those coordinates and see they are equal distance. So Roland is correct. So Roland is good. But the question is, who is incorrect? So Maddie says that it is translated 8 units to the right. Well, again, let's just pick a coordinate and test. We have 1, 2, 3, 4, 5, 6, 7, yep, 8 units. So Maddie is also correct. King, I'm assuming that's how he would pronounce his name, it says that it's rotated 90 degrees clockwise. Unlike the shape that was on the last page, this one is perfectly symmetrical in every direction. So a rotation really wouldn't change the direction this shape seems to be facing. It would just mean that this point would now be this point. And it would mean this point would now be this point. That's all that would mean. So King, although this is unorthodox, for this one particular type of shape, he's right, that would work. Odette is probably the only one who is wrong, because 180 degrees counterclockwise would put the shape down here. So yeah, unfortunately, Odette is wrong on this one. For number 13, this one, we've got two shapes, figure 1 and figure 2. So figure 1, figure 2. Draw those a little bit bigger. Which sequence could show figure 1 is congruent to figure 2? So there's that word congruent. So let me double check, make sure there is no mention of a dilation anywhere. Because dilations, we could cross them out. Nope, okay. So we are starting up here and moving down here. Option A, it says it's obtained by reflecting it across the x-axis and then translating it 2 units to the right and 8 units up. So no, at no point would we be going right and up to go from here to here. So A is automatically out. For B, it says it is obtained by reflecting over the x-axis, so taking this shape and reflecting it down here, and then translating it 2 units left and 8 units down. At first glance, you might think, oh yeah, that sounds good. But then think about what would happen to this shape if we reflected it over the x-axis. If we reflected over the x-axis, we would have, let's see, 1, 2, 3, 4. So 1, 2, 3, 4. This point would be 6 units down. So right about here, I think. And then this one would be 4 units down again. See the problem? Even if I took this shape and I translated it over and up, it's facing the wrong direction now. So reflecting over the x-axis, frankly, was never going to work. We wanted to reflect over the y-axis from the very beginning. See, if we reflect over the y-axis, you can kind of see the triangle has one longer side right here. And we want that longer side to match that longer side. But to do that, we would have to flip our triangle over this way, over the y-axis. And then, once we are flipped over here, we can clearly see our triangle would end up here, and we'd have to move it down. Which means we can eliminate C, because C would say we would have to translate it going up. And that's wrong. We need it to reflect over the y-axis, and then we need it to go down. And I suppose also a little bit to the left. For number 14, it's asking what is the new ordered pair if, let's see, that would say 4, 2 is translated 6 units up and 3 units to the left. So if I took this and went 6 units up, 3 units to the left, you could do this even without graph paper. Because 4, 2, you have to remember which coordinate means left and right and which coordinate means up and down. So if I have a shape that is going 6 units up, I would simply add 6 to the y coordinate. And if it's going 3 units left, well, left would be negative, so I'm going to go 3 units to the left. And that gives me my new shape at 1, 8. That would be the correct answer. And if you're not sure about that, or if this is not something that you think that you could easily remember, just grab some graph paper. I'm going to draw over top of this old graph just to save time, but 4, 2, so 4 over and 2 up, okay? So there's my original point, and then it tells us that we go 3 to the left and 6 units up. So 3 to the left, 1, 2, 3, 1, 2, 3, 4, 5, 6. So that would be my new point at 1 and then 8 up. So either way, you could get 1, 8, even if you're not all that great at just doing it like this. You can grab some graph paper. Number 15, my camera is not even pointing at it. For number 15, this one is asking us to get a new shape using a scale factor of that says 1/4. Okay? I don't know why the printed version did this, but this is partially why I'm glad I did not do a printed version for you guys. So for this one, we are going to be using a scale factor of 1/4. So remember the way that you are going to have to do this. You need to write down the old coordinates and then multiply it by the scale factor. So I'm just going to pick one coordinate that I can see pretty clearly. Let me move the camera even closer. You, of course, could, with your Chromebook, hit Control+ to zoom in and out. But for me, coordinate A is going to be at 1, 2, 3, 4. So -4, 1, 2, 3. So the original A was at -4, +3. And I'm going to multiply this. So this was A. So I'm going to multiply it by, that would be 1/4. So times 1/4. That's going to give me my new coordinates of A prime. So 1/4 of -4, or -4 divided by 4 would be one way to do that, would give me -1. And then 3 times 1/4, so 3 times 1/4 would give me 3/4. And now I can use this information to look down here and see if I have a match. So let's see, for A, -1, and that says 3/4, so far A matches up. B says +1 and 3/4, so B, that first coordinate is wrong, so B is wrong. For C, let's see, I don't even see any fractions for C, and I don't even see any fractions for D. This is the importance of trying at least one coordinate. Yes, ordinarily, doing a dilation and having to do this for all the coordinates would take a lot of time. But you have to keep in mind, they probably set these problems up that you can identify the right and wrong answer just using a single coordinate. So use that information to your advantage. Do a little bit less work. For number 16, for this one, it tells us the vertices of two triangles, and it asks us what scale factor could have happened. So it's kind of the same thing that we did for the last problem. I'm just going to find one coordinate that I think would be easy to work with. So in this case, A, the original A, is at -2 and +4. New A, or A prime, is at -1, +2. So the question would be, what was multiplied to the original to get that? -2 times something gave me -1, and 4 times something gave me 2. Well, most of you can pretty quickly and correctly say, oh, these are both times 1/2, and you'd be right. The trick is that you have option 2, -2, 1/2, and -1/2. It's going to be regular 1/2 because the symbols did not change. If the scale factor had been negative, which frankly, scale factors are never going to be negative, then these symbols would have switched. This would have become negative, and it didn't. So watch out for that. We try to be tricky when we make these tests. Moving on to number, what is this, 17. So we have two rectangles, figure 1 and figure 2, and it asks which statement is true. A says that they are similar. Well, if they're similar, they should have proportional sides. So this top edge, we have 1, 2, 3, 4, 5, 6, and the sides 1, 2, 3, 4, 5, 6. So 6 by 6. And then for this one, we have 1, 2, 3, 4, going down, 1, 2, 3, 4. So I don't know about you, to me those looked like rectangles when I first saw them, but apparently they're both squares, and they are proportional. So they are similar, but because they are different sides, they are not congruent. So they are similar, not congruent. They are not both, and they are not neither. Moving on, we have only 3 more left. So this one, same deal. We are trying to identify if they are similar, congruent, or neither, or both. Clearly they are not congruent, they are different sizes. And then we have to just double check and see if they're proportional. So A has, let's see, 1, 2, 3, and 1, 2. At first you might think that, oh no, these definitely aren't because they're different ways. Well, what if this shape was rotated? So assuming that this has been rotated, this side over here and this side over here should be proportional to 2 to 3. So let's check. 1, 2, 3, 4, 5, 6. Okay. And then this side, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 6 to 9. So will 6 to 9 simplify to 2 to 3? The answer is yes. Because those are equivalent ratios, they are proportional, they are similar. And number 19. This goes back to kind of what we did with our homework last night. It gives us enough information. It tells us that these two shapes are similar. And therefore, we can just look for our 90 degrees. And we can identify this 15 is proportional to the 40. And because of that information, we can say that this 18 is going to be proportional to this x. And the trick is, what was the scale factor? What did I multiply 15 by to get 40? Because I'm going to need that answer to know what I multiply 18 by. So we have 15 times something equals 40. Well, if I divide both sides by 15, I get x equals, I can simplify that. Both of those are divisible by 5, so I get 3 down here and 8 up here. So 8/3. So that is my scale factor, is 8/3. So when I look over here, I've got 18, and I'm going to multiply that by 8/3. Whoop, that should be a 1. I'm going to multiply that by 8/3 so that way I can go ahead and figure out what this new length is going to be. I'm going to take a shortcut here, and I'm going to rewrite this. This is 18 times 8. 1 times 3, that's going to be 3. And I can simplify this a little bit. Because 18 over 3 does simplify, because 18 divided by 3 would give me 6. And then 3, well, that simplified to 1. So 8 times 6, that's going to give me 48. And I should point out, you could also just use a calculator for this. You could have done 8/3 times 18 using a calculator. And that would have worked just as well. And last but not least, it's not on camera again. This one is showing us 3 different triangles, and it demonstrates all of them have 60-degree angles. Triangle X and Y appear to be the same, just Y appears to be either reflected or rotated. Z, on the other hand, is smaller. Each side length is only 3, not 5. And it asks which statement is true. A says that they're all congruent, and that's not true. If they were congruent, they would be the same size. B says the same thing, which is the same problem. They would be the same size if they were congruent. For C, it says that triangle Z is similar to X, and that's true. But then it says it's not similar to Y, and that's not true. And then D says that triangle Z is similar to both X and Y, and that is true. All right, so that is it. That is the study guide, all 20 questions. Tomorrow's test is not going to be the same 20 questions. They will be the same style, they will be written the same way, but they won't be the exact same questions. So please don't study this expecting it to be the same exact questions. Instead, when you are studying this, reattempt it, and then watch the study guide video to see if you caught the mistakes that you made last time or the time before. Okay? And that is really going to be it. Good luck, and bye.